Hi everyone, welcome back to the channel. This is another problem from IIT JEE 2024 and many students again fail to solve this problem properly. This is not a tough problem. This is actually a pretty simple straightforward problem. But as I said earlier also, the IIT JEE has been asking questions which involve a little bit of logical understanding and once you analyze the problem properly and see what's going on, then use the basic concept to solve the problem in just one or two equations. This problem is no different. If you got your concepts right, then you'll be able to solve this problem in 2-3 minutes. So I'll be going to solve this problem and give you some insights and some of my understanding how to solve such problems. And along the way, try to impart some of the concepts involved in such questions. If you want to give it a try, please pause the video and try it out. Okay, so before we start, let's understand the problem. As I said earlier also, I solve problem using 3 steps. Analyze the problem logically, see what's going on. Second, draw the free body diagram. And third, just write the equations. Okay, so let's see what's going on here. So the question is that there is a rod which is kept on a horizontal frictionless table. And that rod is attached to a string which is hinged at the center of the table, let's say some point O. And it is free to rotate horizontally on the surface of the table. And then there is an impulse P which is imparted to the rod at distance x from the center of the rod. Now what happens because of this impulse, the rod should start moving. But there is a constraint here that's given in the question that rod and string, they revolve together, which means that the rod and string, they are acting like a single entity and they are always in the single line and they are rotating around this point O. So they are making a big circle of radius 2L and both string and the rod, they're always aligned. So this is the constant that is given. And we need to find what is that point P, at what distance from the center of the rod, which is x. This is possible. If we impart impulse P, then the rod and a string, they always remain aligned and they start rotating. So let's say this is our rod and this is the string. Let's say tied here at point O, and this is the center point. And an impulse P is imparted here at this point. And it is given that the distance from the center of the rod is x, which is actually, they're saying it is equal to L by N, and we need to find N. So why would rod rotate? Because there is an impulse P. Hence, there is going to be angular momentum. Okay. And that angular momentum will be in the direction perpendicular to the page. Let's say this is our axis. This is Z. And let's say this one is Y. This is also Y. So when P is imparted here, it will try to rotate like this. And therefore, the angular momentum will be inside in the minus negative Z direction. So let's say it starts moving with omega. Okay. And it is going to be inside the paper because it's going in the clockwise direction. Okay. So but the constraint is that they are moving always together, the string and the rod always aligned. Okay, so we can take it as this rod is simply moving around this circle like this. Always the center is going in this, let's say this one. Okay, now what is impulse? So if you write F equal to dV by dt into mass, right? So F into dt equal to m delta B. Now, delta V is nothing but change in the velocity. So this one is change in momentum, and that is equal to F into delta T. And this is equal to impulse. Impulse is defined as F into delta T. So here it is given that P, which is impulse, we can take it as F into delta T or change in momentum. Okay. Now, because of this impulse, there will be a angular momentum in the negative z direction, which is in the omega direction. Okay. So what is that angular momentum? So that angular momentum is I omega, should be equal to I omega, but this is also equal to mv, let's say delta v into r, right? This is also angular momentum. So there is no torque acting in the z direction. So we know that torque in the z direction is 0. Why? Because everything is frictionless. There is no external force here. So which means that angular momentum in that direction should be 0, sum of angular momentum. Okay. So if this is understood, so we can use these two entities and we can make the LZ conserved. So initially, when the impulse is imparted, the angular momentum is, we can simply write P into R. So P, what is R? R is the distance that we have from this place to this point to this point. So this is equal to L by N, which is X, plus L by 2, half of the rod, and plus L, because this is also given that the length of the string is L. So this is the angular momentum at point O because of impulse. And now this should be equal to I omega. So what is I here? 1 by 12 ml square, and plus m we need to take at point O. So the distance is L by 2 plus L. So 3L by 2 square into omega. Okay. So now we can, this one becomes PL, and this becomes 3N plus 2 by 2N, correct? And that should be equal to, this is going to be ml square by 12 plus 9 ml square by 4 omega, which is nothing but 28 by 12 ml square omega. Therefore, P L 3n plus 2 by 2n equal to, this we can write 7 by 3 ml square omega. Therefore, omega as 3 by 14 and ml P 3n plus 2 by n. Okay, so this is the omega. Let's call it 1. What is the force in the y direction? Because this is the y direction. Y direction is here. So what is the total force in y direction? So total force in y direction is 0. That means momentum linear is also conserved. Therefore, what is the linear momentum? Then P equal to change in momentum equal to mv. What is v? V is the velocity of center of mass, which is omega 3L by 2. Because this distance, right here, this distance. Therefore, P equal to m 3 omega L by 2. This is also going to be true, and therefore we can substitute P there, and omega equal to 3 by 14 ml, and P will become m, this is big M, omega L into 3 by 2 into 3n plus 2 by n. So m cancel out, omega will cancel out, and therefore we'll have 28n equal to 9, 3n plus 2, and that is, therefore n is 18. Okay, so this was as simple as that. Now the most important point here was that if this whole thing is rotating together in a single line, string and rod, then we can consider this point 0 since this is rotating around I. An impulse will be the reason why this rod will start moving, and then we just need to take the angular momentum, which is going to be conserved because there is no torque acting in the z direction. Also, one of the things that is most important to understand here is that why would this string remain tight when the rod is moving in the circle? And the reason is because when the rod is moving, there is a pseudo force that is acting along the radius vector, and that will be balanced by the tension in the string, and therefore the string will always remain completely tight. There was some concept to learn here. Most of the problems, as I said, in JEE is going to be concept based, and our goal in this channel is to impart some of the concepts around such problems so that you can score much higher in IIT JEE and get a good rank there. Thanks for watching. Thank you very much. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.